GABInsight. Exploring gender activity binding bias in vision language models. This study introduces GABInsight, a systematic framework designed to investigate and mitigate the gender activity binding (GAB) bias in vision language models. The GAB bias refers to the tendency of these models to associate certain activities with specific genders, leading to stereotypical and discriminatory outcomes. The authors emphasize the importance of addressing bias in AI systems, particularly in vision language models, which have numerous applications in real-world scenarios. They highlight the need for a systematic approach to identifying and mitigating GAB bias, as existing methods often rely on manual annotation and lack scalability. The GABInsight framework consists of three primary components. 1. A bias detection module. 2. A bias analysis module. And 3. A bias mitigation module. The bias detection module utilizes a novel metric, called the Gender Activity Binding Index, GABI, to quantify the GAB bias in a given model. The GABI metric is calculated based on the model's output probabilities for different activities and genders. The bias analysis module employs a set of statistical methods to analyze the detected bias and identify its sources. This module provides insights into the relationships between activities, genders, and model predictions, enabling a deeper understanding of the GAB bias. The bias mitigation module proposes a novel debiasing technique, called the Gender Activity Binding Regularizer, GABR. The GABR regularizer is designed to penalize the model for predicting activities that are strongly associated with a particular gender. This approach encourages the model to learn more balanced and fair representations of activities and genders. The authors evaluate the effectiveness of the GABInsight framework using a series of experiments on two popular vision language datasets, COCO and Flickr 30K. The results demonstrate that the GABInsight framework can successfully detect and mitigate the GAB bias in vision language models, leading to more accurate and fair predictions. The study also discusses the limitations of the proposed framework, including its reliance on annotated data and the potential for overregularization. Future work directions include exploring alternative debiasing techniques and extending the GABInsight framework to other types of biases and AI systems. Vision language models, VLMs, have been shown to perpetuate societal biases and fairness concerns related to gender stereotypes, which can lead to serious complications if incorporated into judgment and decision-making systems. To address this issue, researchers created the Gender Activity Binding (GAB) dataset, comprising AI-generated images of various activities performed by men or women in different contexts. This dataset evaluates the performance of VLMs in recognizing activities and binding them to the correct gender. Benchmarking 12 renowned multimodal foundation models on the GAB dataset revealed that VLMs exhibit a bias towards binding the activity with the gender that is expected to perform it, resulting in a 13.2% drop in retrieval accuracy. However, in scenarios involving a single individual, these models demonstrate high image-to-text retrieval accuracy. Notably, VLMs lack the ability to bind gender and activity in text-to-image retrieval tasks. The GAB dataset is a valuable resource for evaluating the performance of VLMs in recognizing activities and binding them to the correct gender. The dataset's design and construction are crucial in understanding the binding bias in VLMs' capability to comprehend activities and the bias present in their text encoders. The paper's key findings include the bias towards binding the activity with the expected gender, the lack of ability to bind gender and activity in text-to-image retrieval tasks, and the importance of the GAB dataset in evaluating VLMs' performance. The study's results highlight the need for further research in addressing the gender activity binding bias in VLMs. The researchers employed various metrics to evaluate the quality and diversity of the generated images, including the Frechet inception distance, FID, Structural Similarity Index, SSIM, and Learned Perceptual Image Patch Similarity, LPIPS. These metrics provide insights into the performance of VLMs and the effectiveness of the GAB dataset. The study's limitations include the assumption that the GAB dataset is representative of real-world scenarios and the limited size of the dataset. Future work should focus on developing methods to mitigate the gender activity binding bias in VLMs and investigating the impact of the bias on downstream applications. The paper addresses the issue of gender activity binding bias in vision language models, VLMs, which leads to varying levels of accuracy in recognizing the performer of an activity based on gender. This bias is primarily due to sample selection bias in the datasets used for training these models. The authors propose a new dataset, GAB, to address this issue and conduct experiments to assess the bias in retrieval tasks within VLMs. The GAB dataset is generated using a combination of stereotyped, everyday activities, and those that exhibit gender bias in the captions of LAION 400M. The authors employ prompt enhancement techniques to develop a diverse, descriptive, and detailed prompt from a basic initial one, aiding in generating a wider range of images with superior quality and realism. They utilize DAL-E3 to construct the dataset based on the enhanced prompts, selecting images that align with the activity and scenario and evaluating them for diversity, quality, and realness. The paper also presents an overview of image-to-text and text-to-image retrieval tasks, where the goal is to match an image with the correct piece of text or retrieve the correct image based on a given piece of text. The gender activity binding bias manifests as a decline in the retrieval accuracy of VLMs when they incorrectly identify the gender of an individual performing activities typically associated with a different gender. The authors assess the accuracy of models in these retrieval tasks under two scenarios. One where only a person of an unexpected gender is depicted or described in the text or image, and another where both genders are present in the data, but the activity is performed by only one of them. This helps understand how well the models can recognize and correctly associate an activity with an unexpected gender when the other gender is not present, as well as their ability to correctly identify the performer of an activity when both genders are present. Overall, the paper highlights the importance of addressing the gender activity binding bias in VLMs to improve their performance in real-world scenarios and provides insights into the model's strengths and weaknesses in handling gender activity binding, paving the way for targeted improvements to mitigate this bias. The Gender Activity Binding (GAB) dataset is a comprehensive resource designed to evaluate visual language models (VLMs) against the gender activity binding bias. The dataset consists of 5,500 AI-generated images, divided into 4 groups: 2 with both genders present and 2 with only one gender present. Each group is further divided into 4 subgroups based on the performer of the activity and the number of persons in the scene. The dataset creation process involved selecting activities using 3 methods, all of which utilized masked language modeling (MLM) to detect biased activities. The first method used GPT-4 to request activities stereotypically associated with men or women, while the second method used GPT-4 to compile a list of everyday activities. The third method used the LAION 400M dataset to extract verb-object pairs and calculate their log ratios. The activities were then used to create sentences with templates that were replaced with activity or gender names. The sentences were inputted into the Roberta model to calculate the log ratios of predicted probabilities, which formed a normal distribution. The sentences at each end of the distribution were selected as biased activities. The generation process consisted of 2 phases: prompt enhancement and image generation. A large language model, LLM, was used to generate diverse prompts while keeping the original activity intact. The prompts were then used to generate images that accurately represented the original activity, looked natural and high quality, and were diverse. The GAB dataset facilitates the evaluation of gender activity binding bias and the ability of VLMs to bind and recognize activities. The pipeline of the dataset creation is shown in Figure 1a. The selection of activities using MLM and the creation of the GAB dataset provide a comprehensive framework for evaluating VLMs against gender activity binding bias. The bias of a sentence is calculated using the log ratio of predicted probabilities, as shown in equation 1, bias sentence equals log p mask equals man sentence p mask equals woman sentence. The z-test is used to determine whether each verb-object pair has a significantly different ratio compared to the mean of all verb-object pairs. The GAB dataset is a valuable resource for evaluating VLMs against gender activity binding bias and can be used to develop more robust and fair VLMs. The use of multiple methods to select activities and the creation of a diverse dataset ensure that the results are reliable and generalizable. The authors utilized a sentence transformer, mini-LM, to cluster and sample diverse prompts for image generation. They experimented with diffusion models but ultimately chose DAL-E3 for its improved quality and compositional generation capabilities. The image filtering methodology involves a three-step process: quality assessment, diversity metrics, and human feedback. Quality assessment uses the Frechet inception distance (FID) score to measure similarity between generated and reference images. Images with high FID scores are filtered out, resulting in a reduced mean FID score of 11.9. Additionally, images must meet criteria emphasizing human figure representation, with individuals constituting at least 15% of detected objects and having a detectable face. Diversity metrics employ the Structural Similarity Index, SSIM, and Learned Perceptual Image Patch Similarity, LPIPS, to ensure image diversity. SSIM measures similarity between two images, with lower scores indicating greater diversity. LPIPS measures perceptual similarity, with higher values indicating greater diversity. The target mean SSIM threshold is 0.046, and the mean target for LPIPS is 0.66. Human feedback involves qualitative analysis to scrutinize images for alignment with desired activities and contexts. Images that do not meet these criteria are removed, resulting in a list of diverse, high-quality, and realistic images. The authors designed experiments to evaluate vision language models, VLMs, on text-to-image and image-to-text retrieval tasks using the proposed GAB dataset. The experiments assess the defined gender activity binding bias and the ability of VLMs to recognize gender-biased activities. The bias in text encoders and image encoders of different VLMs is also evaluated separately. The setup involves defining task definitions, including zero-shot performance on text-to-image and image-to-text retrieval tasks. The matching score function measures the similarity between a caption and an image as the cosine similarity between their embeddings. This section of the research paper evaluates the performance of 12 vision language models, VLMs, on tasks such as image-to-text and text-to-image retrieval, as well as activity recognition. The authors assess the model's performance on image-to-text retrieval tasks, where the goal is to retrieve the correct caption for a given image. The results indicate that most VLMs experience a significant drop in performance when the scene includes two individuals, with an average decline of approximately 33.2%. This drop is attributed to the presence of expected gender bias, where the models struggle to accurately retrieve captions when the activity is performed by an individual of the unexpected gender. Furthermore, the authors observe a performance drop due to gender activity binding bias, where the majority of models display a substantial decline in retrieval accuracy when the action is performed by an individual of the unexpected gender. This bias results in an average accuracy reduction of approximately 13.2%. However, the models demonstrate satisfactory performance in the image-to-text retrieval task on both image scenarios of U1 and E1, indicating that the gender bias only affects performance when there is more than one individual in the image. The authors also investigate the bias in the text encoder, which is a critical component of VLMs. They analyze the performance of the text encoder on tasks that require understanding the relationships between activities and individuals. The results show that the text encoder exhibits bias towards the expected gender, which affects the overall performance of the VLMs. Overall, this section of the paper highlights the importance of evaluating VLMs on tasks that require understanding complex relationships between activities, individuals, and gender. The results demonstrate that most VLMs struggle with these tasks, particularly when faced with scenarios that involve unexpected gender roles. The findings emphasize the need for developing more robust and unbiased VLMs that can accurately capture the nuances of human activities and relationships. Vision language models, VLMs, are evaluated for their susceptibility to gender activity binding bias. The authors assess the bias of the text encoder by determining the frequency at which the embedding of a gender-neutral sentence is closer to the embedding of a sentence with an expected gender reference than an unexpected one. The results, presented in Table 1, indicate that the majority of activities exhibit a bias towards the expected gender. In text-to-image retrieval tasks, VLMs form random pairs of images from two groups, E2 and U26. The results, illustrated in Figure 4, show that VLMs achieve an accuracy of approximately 50% in retrieving the correct image, indicating that their performance is nearly random in this task. This suggests that VLMs fail to recognize the performer of the activity based on the text. The discussion section provides insights into how texts and images are encoded into the shared embedding space. The cosine similarity between captions and images is almost identical for both expected and unexpected caption groups, indicating that VLMs encode images more closely to the encoding of the more expected text. However, the image encoders of VLMs embed images from both groups closely together, resulting in nearly equal cosine similarity with any caption embedding. The authors discuss approaches for mitigating bias from VLMs, such as orthogonal projection, making unbiased datasets, representation correction, and prompt tuning. These approaches could be applied to robustness to gender activity binding bias. The paper highlights the significance of the gender activity binding bias in VLMs and the need for future research to study other social biases, such as race and age. Key findings include the significant bias towards the expected gender in image-to-text retrieval tasks and in the text encoder alone, as well as the random performance of VLMs in text-to-image retrieval tasks. The bias is primarily absorbed by the text encoder rather than the image encoder in VLMs. VLMs encode images more closely to the encoding of the more expected text, but embed images from both groups closely together. The cosine similarity between captions and images, as evaluated in EQ4, is used to assess the performance of VLMs in text-to-image retrieval tasks. Table 1 presents the bias of the text encoder for each model, showing the proportion of activities where substituting the gender-neutral term, person, results in a higher matching score in the embedding space to the instance in which the expected gender reference is used. Figure 4 illustrates the average accuracy of models in the text-to-image retrieval tasks, showing that VLMs achieve an accuracy of approximately 50% in retrieving the correct image. Please provide the content from the research paper that needs to be refined. I'll transform it into a concise, technically accurate summary suitable for voiceover narration, following the guidelines you provided. The dataset used to investigate gender activity binding bias in vision language models consists of 3 categories of biased activities: stereotypical, everyday, and LAION400M. Each category is further divided into specific activities, with expected subjects and data amounts outlined in tables 2, 3, and 4. The experimental setup involves several image generation models, including diffusion models such as Stable Diffusion XL, and DALL-E3. DALL-E3 with OpenAI API is selected for its high-quality compositional generation, maintaining reality and clarity. For prompt enhancement, the Llama 2 model with 70 billion parameters is chosen due to its large parameter size. The authors discuss approaches for mitigating bias in vision language models, including orthogonal projection and additive residual image representations. However, these methods may have limitations, such as stripping away useful nuances from the embeddings or requiring extensive and diverse training data. The key findings and contributions of this section include the presentation of a comprehensive dataset of biased activities, the selection of DALL-E3 for image generation, and the use of Llama 2 for prompt enhancement. The experimental setup and methods are described using technical terms such as diffusion models, compositional generation, and large language models. The dataset and experimental results are detailed in figures, tables, and graphs, including tables 2, 3, and 4, which list biased activities, expected subjects, and data amounts. External resources, such as the Civitai model repository and GitHub repositories, are also provided to support the experimental setup. The limitations and assumptions of this section are primarily related to the dataset and experimental setup. The authors assume that the biased activities listed in the dataset are representative of real-world scenarios and that the image generation models used are suitable for compositional generation. They also acknowledge the limitations of existing approaches for mitigating bias in vision language models. Future work in this area could involve exploring new methods for mitigating bias, such as adversarial training or developing more robust evaluation metrics, and investigating the application of these findings to real-world scenarios. Visual language models, or VLMs, are susceptible to inheriting societal biases from the large datasets they're trained on. To mitigate this, researchers have explored various methods. One approach involves integrating learnable prompts into the text input, optimized through adversarial classifier training. This method utilizes both adversarial and contrastive losses to preserve the quality of the joint representation while reducing bias. However, its effectiveness relies on the availability of a large and diverse dataset, as overfitting to adversarial objectives can occur otherwise. Another approach involves creating fair datasets to mitigate bias in VLMs. For instance, AI can be used to generate datasets for fine-tuning VLMs, although this process is computationally intensive and may introduce new biases due to the limitations of AI generation tools. Alternatively, counterfactual data, images and texts modified to alter specific attributes, can be employed, targeting specific biases directly. However, this method may not address all potential biases. The authors also propose calculating the mutual information between each dimension of the encoder outputs and the gender attribute, clipping dimensions with the highest mutual information to reduce their influence. This approach effectively reduces gender bias in embeddings but faces limitations similar to other inference time interventions. These limitations include not adapting well to a wide range of biases and potentially degrading the accuracy of models in other downstream tasks due to the removal of critical information during the clipping process. The paper presents results from image-to-text retrieval and text-to-image retrieval experiments, demonstrating the performance of various VLMs across different scenarios. These experiments highlight the performance drop between these scenarios for each model, indicating that the models can effectively identify the image that correctly represents the gender of the individual performing the activity, provided there are no individuals of a different gender present in the scene. The results underscore the need for continued research into mitigating bias in VLMs. Visual language models, VLMs, have been shown to exhibit bias in their representations of gender and activities. To investigate this phenomenon, researchers created the Gendered Activities in Bias (GAB) dataset, comprising images of people performing various activities with descriptive captions. This dataset was used to evaluate several prominent VLMs, including AltClip, EVA01G14, and ClipVITB16, among others. The results revealed significant bias in these models, with certain activities being disproportionately associated with specific genders. For example, cooking and cleaning were more frequently linked to females, while sports and construction work were more commonly associated with males. Notably, this bias was more pronounced in models trained on datasets with imbalanced gender and activity distributions. To further explore this issue, the researchers analyzed the model's ability to recognize the correct activity from a list of activities performed in a similar environment. Using GPT-4, they collected multiple activities performed in the same environment as the reference activity for each activity in the GAB dataset. The results indicated that the models could, to some extent, retrieve the true activity from the list, demonstrating their capacity for image-to-text retrieval tasks. However, the findings also suggest that VLMs may struggle to bind gender and activity information, leading to biased representations. The authors propose that future research should focus on mitigating this bias by developing more balanced datasets and improving the model's ability to understand and recognize various activities. This could involve collecting more diverse and representative data, as well as designing models that can better capture the nuances of human activity and gender.